Good evening, everyone. We'll be starting shortly. Um, permit me. We're just going to wait a few minutes for more people to join, and then we'll start immediately. Thank you. Um, Good evening, everyone. I am Samuel Bangola, an Alpha Students Ambassador, Alpha Microsoft Learning Students Ambassador, and a student of University of Lagos. So this evening, we'll be talking about deploying machine learning models in notebooks using Azure Machine Learning. So we'll get started. Okay, so we'll do a short intro before we move to the workshop. So first, for many of us that might just be hearing of machine learning for the first time, is a subfield of artificial intelligence that focuses on developing algorithms and models that enable computers to learn from and make predictions, just as is shown in the slide. And there are different areas of machine learning. So you have your classification, you have your regression, you have computer vision, we have natural language processing, which is very popular now at the moment or because of ChatGPT, and then so many other applications of machine learning like that. And then you could also mention deep learning as a subset of machine learning. So when you talk about computer vision, or you talk about some more complex algorithms involved in machine learning, then you could refer to them as deep learning. So moving on, which we'll be focusing on today, is Azure Machine Learning. So it's a cloud-based platform. You have so many cloud-based platforms like that, like your GCP and AWS. And it's provided by Microsoft that allows users to develop, deploy, and manage machine learning models at scale. So Azure in its whole is a cloud-based platform, right? Azure Machine Learning is a service or a resource in Azure. So you could use Azure Machine Learning for so many things: training your model, doing some visualizations. The same experimentation you can do in your Jupyter notebooks can be done with Azure Machine Learning. You have your automated machine learning, where you don't have to actually have to manually code the or import the models or models that you'll be using to train your data set and all that. It will just randomly use, depending on maybe classification or regression, it will make use of any of those algorithms based on the data set you're using without you doing anything, just some clicks and you are good to go. So moving on now, since we've established a background in what we'll be discussing today, the first thing we need to do is to set up Azure Machine Learning. So the first thing we need to do is create a resource group, and then we'll create an Azure Machine Learning workspace. But before we move to that, let's see all the things that we would need. So we have here compute targets, which we would need. So compute target is just like a virtual machine. But even before that, since we're going in stages now, from setting up our Azure Machine Learning workspace, what exactly is a resource group? Because we'll have to create a resource first. So resource group in Azure is a logical container for grouping and managing related resources in a subscription. So it contains virtual machine, storage account. So it's just like an embodiment of all the things that you need if you're actually going to work locally. So you're working locally, you obviously need your storage, you need the machine you're using, right? So that's like virtual machine in this case now, which is your PC. You need the database that you're referring to and all those things. But now it's virtual, so everything is made available for you. So this is just like a description, a visual description of how Azure works. So from your Azure portal to your Azure Resource Manager and all the other tools that you'd be making use of, or you could make use of in your Azure Resource workspace. So we mentioned compute target earlier, right? And I already mentioned that computer get is just like a virtual machine. So say computer get is a compute resource that you can use to train machine learning models, run experiments, and deploy models. When you create a computer get, you need to specify the type of compute. So this would discuss more as we go along. So first, we mentioned that we're going to create a resource. If we move back here, we need to create a resource group. And then for you to follow successfully in this particular event, as a student, you have access to Azure for free. So you could head over to this link here and sign up and create an account using your student ID, or if you have if you are already if you have the student package for GitHubs, you can just sign up to Azure for students using that GitHub package. There's an option for you to do that. So you can see that you get $100 Azure credit to do whatever experimentation you need to do. You don't need a credit card to start up. So once you sign up, just plug and play, and you're good to go. So let's start now. Create our resource, and as you can see, there are so many things or resources that are available to us in Azure. I believe we are very familiar with OpenAI, so you have access to the Azure OpenAI, the OpenAI services on Azure itself. So whatever thing you want to do from the ChatGPT API itself was just recently integrated into this Azure Open AI resource. So you could make use of Azure for anything whatsoever you choose to do. So I just want to show us a sample of some of the things that you'd need. But then let's continue and head over to what we'll be focusing on, which is Azure Machine Learning. So you can search here. After clicking create a resource, you can just search Azure Machine Learning. So we create. So to create your workspace, you need majorly two things, which are your resource group and the workspace name. So you can decide to create a new resource group if you don't have anyone already existing. So we can name this. So we can name this deploy with Azure ML, and we can name our workspace prediction. So prediction diabetes. Since we'll be focusing on the use case we'll be focusing on is a diabetes classification data set. So click review and create, and we just wait for it to load. And then okay, it has reviewed it, and then we can click create. Okay, so it's showing deployment in progress, and then once it starts, we can then launch our Azure Machine Learning Studio. So for those that are following along, you can just follow the same process as we're going through. So while it's loading up, let's move on to understanding different computes that we have. So first, we have the compute instance and compute cluster, which are the major compute that we'll be using today. So compute instance says here that it behaves similar to a virtual machine, which I already earlier referred to, and it's primarily used to run notebooks. It's ideal for experimentation. So compute instance provides you the virtual environment, right? Or let's say the virtual machine that you need to run notebooks and other experimentation that you'd have done normally on your notebooks or your Jupyter notebook on your local system. So you also have compute clusters, which automatically scales up or down to meet demand. So you can use your computer clusters to run jobs, right? And what jobs does basically refers to is a machine learning jobs execute a task specified, right, to a computer get. So what that means is that if you are training a model or you are trying to do a deployment or something, you have to have access to a compute target. So running a job is similar to that. Running a job is just basically that, training your model when it's assigned to a particular compute target, and then it comes up as a job. It's just a terminology. It's just like when you say you're training your model, right? And then let's say you save the model or you document the process of training the model. That's just basically what a job means. So let's go back. We can see that the deployment is completed, and we can go over to launch the studio. All right. So this is the Azure Machine Learning Studio. I earlier talked about the automated ML, which you can use to run various machine learning models without actually doing any code at all. You just need your data set and maybe a few other things and plug and play. But obviously, you need the idea of how machine learning works to know how to make use of automated ML. The designer is also another machine learning tool, just a visual representation. So where you have like uh, a hierarchy or a workflow, right? So let's say from your data set, you have another workflow that you plug into the left. Like it's just like drag and drop system way of training your model, and it's actually very simple and straightforward to use. But now we'll be focusing on using our notebooks, using the models from our notebooks. You've done some experimentation on your local system, and then you want to know how you can actually use Azure Machine Learning to deploy these models with little code, like very, very little code. So we mentioned that we need to compute target with compute instance and compute cluster. And from what we refer to here, these are the types of the compute instance and compute cluster that we'll be making use of. And these types have different capacity or storage they could make use of. So as we're creating, we'd see what I'm referring to. So we said we'll be using the standard DSS1 version 2, and then this automatically picks the nearest location to you. So with Azure Machine Learning, you have access to GPUs, and you also have access to CPUs. So you could see you have a 12 gig, 56 gig RAM, GPU here and all those. So, but we don't need to make use of that much. So we're just gonna stick to this, and then next, you can name our computes. So let's just say classification compute cluster. So just to have a unique identity, and then we create. So that's just all we need, and we create. So we can just wait for this. Okay, it's done already. You could refresh it to see. And then the compute instance also, the same thing, the same type. And then would name it similar to what we named compute cluster, but we'll just change it to cluster at the end. I mean, to instance at the end. Okay, so classification cluster instance. Okay, saying that it's too, compute instance. It's too long. So let us say classification instance. This should already exist. Okay. One. Yeah. All right. So with this, we'll create this compute instance. And for you to run the terminal on Azure Machine Learning, you require a compute instance. So this is an important part for us. So the what we'll be making use of is this.
Hello, sir.
Hello, do you have any question?
No, I can't see your. Can you please share your screen? I can't see it. I can't view it.
I'm currently sharing my screen. Or can you? I don't know if others have the same issue.
No, we can see it.
We can see your screen.
I can see your screen.
Maybe you should just try and end the meeting and come in again. Probably that will fix it.
All right. Okay.
Okay. Yeah. Okay. So the everything we'll be needing for this event is found here. So this is just the meeting description. The data sets. This is a test for the predictions. And then this is our notebook that we've used to experiment. So let's assume that we already worked on it on our local system. So whatever you're using Jupyter Notebook or you're using Visual Studio Code, the notebook in Visual Studio Code, right? And you've done your experimentation and you pushed everything to GitHub, right? So you could actually even still make use of Visual Studio Code. You could connect your Azure Machine Learning workspace to GitHub. To your Visual Studio Code. There's an option for you to do that here. So you can just connect to your Azure terminal and then you can push everything. So, but we don't really need to do that in this case. So everything we're working with will be here in our notebook. So while we're still waiting for the compute instance to create, this is a link to the GitHub repository. Right, so you could just copy this while we're waiting for this. So the same commands that you use in your terminal if you wanted to clone a repository is the same you'd use in the terminal here. So this is still loading up.
Sorry, I can't see your screen. No.
Are you using your browser? Probably maybe try switching to desktop mode. Maybe that'll fix that.
Okay.
We're still waiting for this to come up. Okay, so while we're waiting, I don't know if anyone has any questions so far based on what we've talked about.
Uh,
I don't know if anyone has any question at the moment.
there is question.
Okay.
Is this a video? Is it going to be recorded? Because I'm been having some network glitch.
Yeah, it's recorded. It's recorded. So you
Okay,
have
thank you.
access to it. All right.
Thank you very much.
Okay, so while we're still waiting, let's go over some theory that we'll still be making use of. So we talked about the types of compute already, and then while we're going to be working on the deployments, would come across something called the instance count, and that just refers to the number of virtual machines that will be used on that with that compute targets in your Azure Machine Learning Studio. So whatever type it is, so for example, as written here now, if you choose this type of virtual machine and you set the instance count to 2, it will create 2 virtual machines of that same size, and then it makes it faster. So let's say you're running out of storage or you're running out of speed, everything just works, like everything is amazingly optimized. If you have to, you could also make use of 3 virtual machines to run those experiments. So that's just basically what instance count means here. So, and like I already explained, it can affect the performance and then the cost of your compute target, because Azure will charge you for compute. So like the resources you are making use of, like your virtual machine, and then Azure will also charge you for storage. So depending on the data set you are working with and all that, once you are making use of some things that will require storage, even running this compute has some storage behind it that is using to run, right? If you check through here, you'd see um, the size and everything. So 2 gig, 28 gig disks and all that. So all the storage that you're making use of will also be charged along with your compute, like the processing and everything. So now we have our compute instance running. So we can move to this section now, which is our notebook, and then open our terminal. So you can see that it makes use of the compute instance to open this terminal. And then the compute instance is making use of is the one that we already named. So you can see compute instance 1, the one we just created. So cloning the repository now. Okay, we have that done. So you can just refresh for it to show up, and then we have all the resources that we would need. So like we said, we're working from our notebook, right? And then we're just going to run through and see if we're actually working on a local machine, how it would look like. So, but to run this now, we would have to change the kernel here to Azure, Python 3.8 Azure ML. So once you have that, then the files or models you need to install are already like pre-installed already using this. So you won't be having so much of import errors and all that. So now running this, I think many of us will be already be familiar with pandas. So importing pandas as PD, importing numpy as NP and the likes, right? So this directory, everything is in the same directory. So we just need to we can edit that, run, check through the data set. So we can see that we're dealing with pregnancies, plasma glucose, diastolic blood pressure, and other features that could determine whether a patient is diabetic or not. 0 represents negative, meaning the patient is not diabetic, and 1 represents positive, meaning the patient is diabetic. So we've assumed that we've experimented with this throughout on our local machine, and this is just to like doing a reconfirmation or something that, okay, let's see if it will still work the same way on Azure ML, right? So, and we can see that we have the same results, no errors or no issues, and it's working just fine. All right, so next, right, from this, after getting the code and we've run through the notebook and experimented, the first thing we need to do is convert that notebook to a script. So now, if you actually want to do deployments, deploy your models and other things, I think many of us are already familiar that we cannot do that with our notebooks because our notebooks focuses on experimentation. So now, if you want to convert those lines of codes and commands that you've already worked on to be able to be used for deployment, you have to convert them to scripts. And one major way that you need to do that is, by converting your codes to reusable functions. So we have the template here already as train.py, and then we've imported most of the libraries that we need to do. We don't need to, so that we don't have to go over everything from scratch. So first we can see here that it says, we should enable auto login with MLFlow. So basically, what is MLFlow before we go and do that? So MLFlow is an open source platform for managing the end-to-end machine learning lifecycle. That's just well, I say dictionary definition. So basically what MLFlow does help you do is to track your experiments, your training and everything. And as it says here, that it can easily manage different versions of your models and track their performance metrics over time. So it's just like when you do logging, right? You're training your model, and then whatever warnings or whatever errors or everything that comes up is stored somewhere because you are logging with MLFlow, and then you can just refer to those things. Even the model that was trained and everything is kind of saved in a way, right? So let's import MLFlow, since we have to make use of MLFlow for login, and it says we should enable auto login. So to do that, we just need to do MLFlow.auto log, and then we have to complete this function. So just like you did with your notebook, in your notebook, the experimentation and everything, it's the same process. So you had split data here, so we can just copy this. It's still the same command that you use in converting this notebook to scripts. So we have this. The function takes in the data frame, right, from the input here. So we can just try to, after splitting it, then the next thing is we already imported train tests split at the top here, so we don't need to do that again. And then we'll split the data sets. So for example, we're splitting it to 70%. So this test site just means 70% for training and 30% of the data set for testing. And we saw that we had 10,000 rules, so meaning we have 7,000 rules for training and the remaining 3,000 for testing. And then we return this because this is what we need, and this is what is being called here. So by the time it calls split data, it gets this out just as we've defined here. So we could just try and make this look more reasonable so everything doesn't look scattered. So with this, we're good to go. So we just save this, and then before we actually even train the model, one way to train the model is using the terminal also, and then just like the script you have here, run script as a command job. But for this, you can use any, but for this event, we'll be training with the terminal. So we can just test out and see if this script actually even works, right? Which is also like training the model. So we'll move into the directory. Right, and cd01. Then we can run the file. So train.py. Then we already referred to it here. As you can see how we're going to refer to the input variable training underscore data. So we have training underscore data, then diabetes.csv here. So we run this, and then we just we wait. So we can see that it's run now, and then you can see command job. This gives it a random name, running, right? So once it's done, it says completed. So now we successfully trained this model, right? So, but before we move to the job now, I just want to quickly explain if we didn't run it from our terminal, and like the compute cluster that we made use of, we could actually use it to run this particular script as a job, right? As a command job. So we have this, you make use of Azure AI ML model, your subscription ID, the name of your resource group, you can get access to here. So your resource group, your subscription ID, and all that, you get access to that there, and your workspace, the name of your workspace, which is what we have here, that and prediction on the diabetes. And then you can run through. The beautiful thing about working with Azure or any of Azure resources is that you have already predefined templates that you could make use of, do your own edits and work with without doing so much. So you can see that this here refers to a cluster. So we would just probably rename it. I mean, we would just rename it to the name of the cluster we gave, which was classification compute cluster instead of AML cluster here. And the name of the script, it is, we have train.py here, the directory and all that, and then you run this code and it does the same thing as we just did, running in the terminal, and then which trained the model. So let's go now to the job that we just created with Azure. So you can see the parameters in the logistic regression model, different things. You could actually do some hyperparameter tuning if you wish to. And from the notebook, you could see that we had a default reg rate there, which is a hyperparameter that you can change anytime. So it was default here, so we didn't need to actually set that again while running it in the terminal. So moving back, you can see the training accuracy. You can see so many things. We move to metrics. You can see all these other things. Your recall score, which are evaluation metrics for a classification problem. You could check your confusion matrix. It generates all this for you. Simple, no stress. You know, you could check out your output, all the logging that you did with the MLFlow. Everything is here. Everything is here. So you could actually even get the requirement. Everything that was used to train this model, you have it all here. So let's say you actually want to recreate this model somewhere else. You have your requirements file that you could just load up and pip install straightforward like that. You know, everything you need is here. Easy. That's very easy and straightforward. So the next thing that we would want to do now, after we've created this job, is to register the model. So we can register the model. It just shows us already that is MLFlow type. So there's a wonderful or beautiful integration with MLFlow in Azure Machine Learning. So it's something that you could is highly recommended for you to make use of to log your model for training. So we can just name this diabetes classification, right? And then register the model. So we have the model registered here. You can just move, and we have this. So the next thing for us now is to deploy. But before we deploy, one thing about Azure, or for example, working with the Azure Machine Learning Studio, is that when you see or when you observe that you don't need a particular compute anymore, it's advisable for you to stop or even delete. In fact, delete that particular compute entirely, because you have a running cost here of for this particular compute is $0.09 per hour. It probably is written somewhere here, but the cost, you are shown the cost and everything, and then you could run out of quota. So quota just basically defines the amount of or the total size of virtual machine that you could make use of, right? So, and you see that you don't need a particular resource or compute anymore, you could stop it and delete it completely so that you could run other things. Because if we try to deploy this model now without deleting this computer instance, or for example, the compute cluster, which we didn't use eventually, you would come across this error out of quota, meaning you don't have enough in your subscription anymore to register that model, because you're using you used up the total size of virtual machines that you could make use of. So like the number of cores, right? So we could see something like if we open this, you see a number of cores. Probably that will be shown. Okay, so you have 2 cores here, right? So once you've exceeded the total number of cores, for this construction, it should, I believe it's 6 cores. So once you're exceeding that, you would not be able to run certain things anymore. You're not able to run certain things anymore. So we'll wait for this to come up, to stop, and then we'll delete this compute instance. Do we have any questions so far? I believe there are no questions so far. Okay. So we'll just wait a bit again for this to stop, and then we delete. Okay, so it has been stopped, then we just delete. Okay. All right. So this is just a sample use case of what you could use Azure Machine Learning for. There's so many other things you could use Azure Machine Learning for. It could be a very heavy project beyond the this basic classification model. So like I said, you have access to GPUs and very high-end CPUs also to run heavy models, do heavy predictions, and so many other things. It's just limitless while we are exploring. And then this is just some learning parts you could actually lay your hands on, right, on a Microsoft Learn to learn more about using Azure for machine learning or Azure in itself. And the link to this slide will be provided. So I was waiting for this compute instance to get deleted. And once it gets deleted, we'll be able to deploy our model here. So we have just one version here. No endpoints at the moment because we've not deployed it. You check everything here. The model, just like you'd work with the model we saved as a pickle file. If you're going to maybe do some, if you're working with your notebook, you most likely have saved to a pickle file. Then maybe you're making use of the Flask. You import this back. Load up the pickle file and then do your create your API with Flask and all that. There's so many other ways you can do this, but then Azure Machine Learning is a very beautiful way doing it with low code too. So we have our computes deleted already, this compute instance, so we can go ahead to deploy our model. So we click real-time endpoint. So deploy model using real-time endpoints wizard. So we can just leave this endpoint name as it is. Next, we have a model. That's a model we're making use of. Deployments, name, environments, compute. So as shown here, we're going to be making use of standard DS2 version 2, as we can see here. So we select this. If we hadn't deleted the compute instance, some of these things loading up here will say out of not enough quota. So as you can see below here for some virtual machine sizes, so you do not have enough quota for the following virtual machine. So some more in this list which we have access to would not have been possible if we had not deleted that compute instance. So it's just some of the things you need to have at the back of your mind while working with Azure or Azure Machine Learning. So we just need one compute instance and then we're good to go. So you can allot 100% of the traffic to this endpoint, since we're working with only one endpoint at the moment, and then create. Okay, so while we're waiting for this deployment to finish up, we can take some questions if you have any question at the moment. Does anyone have any question at the moment? Seems like there are no questions. Okay, so All right, so would play a game now, a Kahoot game, and then like you probably saw in the description, you'd have the opportunity of winning LinkedIn Premium voucher or an Xbox Game Pass Ultimate subscription for 3 months. So let's just play this now. So this is not completed yet, right? So it's showing deployment completed. So that's just like a first phase succeeded, and then it starts doing the I would just say proper deployment now, creating the endpoint and everything. So while that is still on, we'll take this now. The Kahoot game can only take 10 people, and then if you are using your phone, I would recommend if you are using your phone, I would recommend that you use the desktop mode. I recommend I use the desktop mode so that you can see the questions. If you are using your phone, it will only show you the options, right? It will only show you the options. So the first people to 10 people to get in will be able to play the game, right? So head over to kahoot.it and then input the game pin that is showing. So we just wait for people to join in. Like I said, if you are using your phone, switch to desktop mode so that you're able to see the questions and the options clicked. But if you are just using your normal, you are just using your normal phone like that without using desktop mode, you won't see the questions. I mean, you won't see the options. You just see some graphics representing, um, yeah, like colors representing the options, but you won't see the words on the options. Okay, so we're still waiting for more people to join in. This person that I'm seeing here shouldn't be allowed to play this game, but either way. All right. We'll wait for others to join in. Okay.
Sorry, what's the game pin?
5423530. 5423530. Like I said, if you are using your phone, switch to desktop mode so you can see the options and the question together so that it's fair for everyone. Okay, we're still waiting. Okay. We just have 3 more people to join in and then we'll start. Okay. We'll be starting soon. So if you are still trying to get in and you're having any issues, you can just speak up now and then so that we can start. The game pin again is 5423530. Head over to kahoot.it, and then we'll start shortly. And for those having issues, I'll try and read out the questions and then the options. Okay, we'll be starting shortly. Just one more person. Okay, so we're good to go. I don't think if anyone still has any issue now, should try to just one more person. One more person, and then we start. All right. Okay. I'm going to look the game now. Then we start. Okay, what is machine learning? The first option says subfield of AI that focuses on developing algorithms. Second option says that's the blue one, a database management system. Third one, a programming language. Fourth, a cloud-based platform. Okay, seems like some people didn't answer at all. Okay. Yes, so that's the answer. A subfield of AI that focuses on developing algorithms and models. So moving on to the next question. We have Joe ahead. Okay, that's nice. Next question. What is MLFlow? The programming language, the amount of data that can be processed on a computer, get open source platform for managing the end-to-end machine learning cycle, and a type of virtual machine that is designed for machine learning workloads. Okay, almost everyone got that. Okay, who is ahead now? Joe is still ahead. Nice. All right, so are we ready for the next question?
Hello, please, can you please call the code again, please?
Okay. You can't join in anymore.
Okay,
We've locked
okay.
it. Yeah. Thinking. Yeah.
All right.
Yeah. So Azure doesn't charge you for storage, true or false? True on the left, false on the right. Okay, that's nice. I think a lot of us have been following. That's nice. Joe is still ahead. Wow. Okay. Next question now. What refers to the number of virtual machines that will be used to create a computer yet in Azure Machine Learning Studio? Job, instance count, compute cluster, endpoint traffic. Okay, so only one person got that right. Wow, and that was like the last thing we talked about. Okay, can we still hear me?
Yes.
Okay, so
You are muted now.
Joe is here, so let's move to the next question. The last question, actually. Okay. No, these cannot be contained in a resource group. Everything we already mentioned. So let's get the first place. Wow. Okay, nice comeback from Kunliho. Nice comeback, nice comeback. So just message me or try to reach me at the end of the meeting so you could get your reward. That's all for it. And then we're coming back now to our endpoint. Let's refresh and see if it has been successfully created. Okay, we're still waiting for this to get completed. So if you have any questions, we can take them now. If you have any questions, we can take them now.
Okay, I wanted to ask, is it possible to... Can you hear me?
Yes, I can.
Hello?
I can hear you.
Okay, yes. Is it possible to do all of this without the notebooks? Because it looks like I can just go into the ML Studio and start writing code there. So do I have to use notebooks?
No, you don't. You don't actually. You don't have to experiment on your local system first. You can do everything from scratch here, right? You can do everything from scratch here. So let's say you created this folder and you can just, create new file or something, whatever you want to name it. So it already gives you samples here. Whatever, whether you're working in R or you're working in whatever language you're working with, yeah, supports Python and R basically at the moment. So you can create your notebook, whatever you want, but we can't do that now because we've already deleted our compute instance. And to work in this place, in this environment, the notebooks environment, we have to have a compute instance, right, so that we can run it across a particular terminal. So that's just it. So you can create everything from scratch working here without anything. You can actually even go to a different environment, right? So you have something like this. If we still had the compute instance on, you could go to a new web page. You have like how exactly Jupyter Notebook looks like, and then you can run all your experimentation there and just save it, and that's just it. So it's like a virtual space, virtual environment that you can do anything you want to do. You can run it from scratch here. So that's just it. I don't know if that answers your question.
Yes, thank you.
Okay. Showing us that it failed. Okay, so what we can do now is we can delete this again. Can delete this endpoint. Right, so this is some of the errors you could come up with, right? And if we wait or see, we probably see something like out of quota or something. So we'll just delete this endpoint and delete the cluster that we have here. We can just wait for this to get deleted. Okay, so I'm trying to waiting for this endpoint to get deleted, and then we would just delete this compute cluster since we're not making use of it. You can just refresh. Okay, so resource not ready. User container has crashed or terminated. So this is now a quota error. So you can just follow whatever this is. You could just follow up and see, what could be happening, right? But then, once we delete this and we run the deployment again, we most likely shouldn't get the error after deleting the compute. So resource separation. Resource separation. The resource separation. Okay. Still waiting for this to get deleted. So you can actually just delete this compute. So waiting. Okay. So I'm just waiting for all this to get deleted, and then we'll run the deployment to see what could be wrong. Okay, this is taking much longer. Okay, so the beautiful thing about is deploying with Azure Machine Learning Studio is that it creates the API endpoints for you automatically. You even generate code that you could use for deployment. So by the time this is successful, you'd see something like tests, consume, deployment log. So you could track how the API is being used and so many other things just like that. It's a very, very useful approach to deploying your machine learning models. Okay, so still waiting for this to come up. And then once they're deleted, we can actually get to work. Okay. Yeah. So sometimes you could take this time to delete this much time to delete your compute clusters and instances. So it's something quite important to note to how when you're planning how do you work, and then also when you're done with your experimentation and everything. So for example, now let's assume that we've done our deployments, we've done the testing that we want to test, and that's just it. You're not leaving it for much longer. You're not going to continue with it. You just did some experimentation. So it's very important that you make sure you delete all this, like just like we're doing now, but right now we're still going to rerun, right? So we delete all these, delete the endpoints, delete the model, delete the jobs, right? You might not necessarily need to delete this, or you could just go straight down and then move to resource and then delete everything associated with that resource. So it's just that simple, yeah. Just as simple. And then if you don't delete these things, they are still, it's assumed that they are still running, and then you still be charged for compute and storage. So it's very important that, once you're done with your experimentation, and if you know you're not going to work further with what you worked on, you delete all this before you move forward. Apologies that this is taking so much time to delete. So while we're waiting for this to delete, I mean, we could actually have even left this on. Let's try and create a new. There was no need for me to change that. Okay, so we're working with this DS11 version 2. Right, so classification cluster 2. Okay, let's just let's create this, and then this time around we're going to use we use the compute cluster to run the job. So now we've the compute cluster has been deleted, then the endpoint also has been deleted. So now this time around, let's train the model, right? Okay, we still need a compute instance, right? Let's train the model, because from the errors you can see that it's saying some things are not displaying as they should. So we will train the model again, but now we'll use that notebook, right? I mean, it's we shouldn't try the same thing again. So let's name this classification instance 2. Okay, to accept that, and then we create. So once this successfully creates, I mean, once this is successfully created, we can move to our notebook and run our script. Right, so we have this. This is still creating this, so would make use of this notebook, right? So while it's getting created, all we need is this. Let's edit this out. The subscription ID is this, so we replace that. Then resource group, the resource group is this, so we replace that with it. And then the workspace is this, predicts diabetes, so we replace it with this. Right, so that's for that point. And then we have our model as train.py, so we just need that. This is the environment, this is the setup that we make use of. The name of the compute cluster that we created is classification cluster 2. So let's name that as classification cluster 2. And then we have, okay, this display name and all that. So this is totally fine. So we can just, we have this now. And then the code, so where it's get the code is just the root directory. So you can just clear this out. So while we're waiting for this compute instance to come up, we already have all we need to create the job with this particular notebook. So you might not really need to understand what is happening in that notebook and all that, since, but then along the line, you know what is used for. You probably don't need to know step by step and all that is going to happen. So, but then to explore more, like I said, we have some resources here that you could check through to make a deep research or understanding of how Azure Machine Learning works, and other resources there, right? So probably if you want to go into machine learning operations also, there are learning paths that you could make use of. Okay. Just waiting for this to create, and then would run a new experiment. I think the endpoint is already deleted, so yeah, good to go. So once it starts up, when we move on. Hello, do you have a question? Do you have any questions? Okay, so it's running now. So let's go on now to work Azure ML, set that to Azure ML, and then let's run this. So okay, so package not found, so we need to pip install it. So let's just do a pip install. It's just with the command that we have here. Okay. So once you run that, it installs it, and then we can make use of it. So the same thing you do if you're working on your local desktop or local machine and all that. So if we run this now, it should tell us that it can find it. Okay, so that's it. We've already done all this configuration. So it runs, you can run this for it to get it. And then finally train the model. We can just confirm and see if we have the right names. The compute cluster that we created was named classification cluster 2. And then yeah, so okay. Okay, you can see it's running its job. So while this is still loading up, it will let us know when it's completed. So we'll just wait a bit. So while we're waiting for this to run, Okay. So it's almost done. You can see all the details that's making use of requested one node, classification, cluster is resizing and all that. So yeah, you can refresh and just wait for it to successfully create the job. Check all this and see still coming up, right? And refresh again. So the command that we run, everything is loaded up here. So this environment just represents all the packages that are being used, right? So for example, your scikit-learn and the rest of them, you already have them in that, just like representing a virtual environment. So this is just basically what the environment here means, right? Okay. This will come up shortly, and then we'll be able to register the model and then deploy. Okay. Okay, we can see what's happening here, resizing, same thing. Okay, you can see that it's saying that it's running now. It's running now, and then it should be successful soon, and then we'll be able to register the model and do a deployment. So right now, we're using the compute cluster to train this model, and by the time we're done training, we'll no longer need the compute instance, right? So we can just delete that after running the model. I mean, after training the model and then registering the model. Okay, still resizing here. Okay. Saying succeeded here. And then probably this should say successful soon. Finalizing. So you can see the parameters used here already. I know that MLFlow, auto login, and the rest. So we still have probably the same training accuracy and the rest of them. Let's refresh, okay, and it's completed, right? It's completed, so we can, if you want to check through, you can still check through the metrics and everything, right? Outputs, your confusion matrix, and the rest of them. So still basically the same thing that's being made use of here. So right now we can actually we can register the model, right? To register the model, maybe we can even delete this model so we can name it the same way. So this is diabetes classification. So we can name it, we can just name it diabetes classification 2, right? So register model, next, diabetes classification 2, next, then we, okay, so we go into the models, and then now we can delete this. We don't need the compute instance anymore, right? So we just delete this and then would register the model. I hope this deletes fast enough so we don't take too much time again. So these are some of the things that you might encounter while working with Azure Machine Learning. So you just need to understand what these errors are, and like he already even provided, so we didn't have to move to start searching somewhere else, or if we're doing a normal code, probably would have gone to check Stack Overflow or something. So there's already a troubleshooting guide here to check what possibly could have gone wrong, and then you can work with that. Then probably if you don't still find any solution, there are GitHub documentations or issues where people respond to and people have responded to such errors if they've encountered such. So once this is deleted now, we'll be able to deploy our model, and then we'll test it, and that will be it. We'll see how we could make use of the endpoints and everything, consume the API and all that, just as you'd do with any other tool that you might use. Okay. 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 Um, okay. This is rounding up, and then hopefully deploying the model doesn't take as much time. Okay, this should get deleted soon, right? And then we can go ahead to deploy the model. So we are deploying using the same with same compute. So we can see now it shows us that we don't have enough resource, right? We change this to 1, it's still saying we still don't have enough quota to run this, right? So these are some of the issues, errors you might come up with in terms of your subscription and the amount of, the maximum amount of calls you could make use of. So that's why it's necessary for us to delete the compute instances. We're no longer using it at the moment. So what we're waiting, we only need the compute instance to work with the terminal. So, for this particular scenario, so once you're done experimenting with your notebooks and everything, then you don't actually need the compute instance to work. You can just delete it. Like this now, you'd see that you'd still be charged if everything is still running. So we have our compute instance deleted now. right? You can just refresh to confirm that. Okay, deleted. So we can deploy our model now. So let's leave it with this name. Next, we can use, but we only need one instance now, and we're making use of DS2 version 2, not DS1. So change that to DS2 version 2. DS2 version 2. It should actually allow us to run this. What is just an error somewhere? Let's refresh again. Okay, so we run this now. 100%. Next, then create. So it should work this time, and then we're able to see how everything looks and how we could actually interact with this API or the endpoint that is created. We could also call it an API. Okay. So I will just wait. Any questions? We can actually take questions now. If you have any questions, then we can take them. I don't know if we're still together.
Yes, we are.
Okay. Thank you. Okay, so that is like the first step succeeded, and then we wait for this to run, and then we'll be good to go to test. Progress. Okay. 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 So you could make use, you check here your deployment logs. That's once this is successfully completed, we're able to track our deployment logs and every other thing. You know. So okay. Okay, so scoring scripts, auto-generated, everything is loading up. Can view the metrics of this endpoint, but though it's not completed yet, right? It's not completed yet. You could see some of the features of the yeah of the endpoint. So something like your requests per minute and other things you could see here. Okay. All right. So other things too like that. So yeah, you can always explore this to see what is happening with your deployments and how it's going. So yeah, we're just waiting for this now. Once this is completed, we'll be able to run some tests and see how everything just looks. Okay. So you can see REST endpoints here. These are some of the URLs we'll be making use of in our deployment. Okay. All right, so we can just, while we're still waiting for this, we can just do a refresh of what we did. Creating the compute instance on the compute cluster. I went to terminal, created everything that we needed to create after cloning our repository. And like someone asked, you can actually do everything from scratch here, right? So you're running your notebooks and everything, and then we use this particular notebook to register our training script, which is this, after configuring everything to in forms of functions, which is reusable. So running this, and then we have a job here, which represents our model. You can explore this, you can check the evaluation metrics, you can check the hyperparameters that were used in the model training, training accuracy, confusion matrix. Everything is generated, the ROC curve, everything is generated, and everything is just very easy to use. See, this what login does for you. So you could see everything coming up here. So you can see MLFlow tracking this and all that, splitting data, training data, all these were displayed from the function. So like the print, this, print, that, everything comes up in the logs. And then you check what code was actually used to train everything. You have this, you can't, it's just very straightforward to use, right? very straightforward to use, and if you you could explore a lot of more other things like we mentioned with automated machine learning and the Azure Machine Learning Designer. Okay, this is taking some time to complete. I believe it shouldn't take so much time from now on. Okay, and just keep refreshing to see. Hopefully it comes up soon. If we see from the last one we did, when it said completed, endpoint deployment field, endpoint deployments completed. Sounds like it used about maybe 14 minutes to complete from this time, and we used about 10 minutes from the time you started now. So it should get completed very, very soon. And then we'll be able to test out our endpoints. Okay. Apologies again for the time. All right. So, I mean, we could always get errors while working with this. So, this is some of the ways we could rectify this and fix this up. So now it shows us completed and then it's successful. That's it, successful. So you can see from here now that we can test out the endpoints. We can test out the endpoints. So let's we have some sample things here. I wrote some tests, so we can just copy this out and run it on the endpoints to test, and then we'll see how we can make use of. Okay, and run this test, and you can see okay, and it works pretty fine. From that, you'd see that you have a prediction of 0, which is not diabetic, then 1 representing both diabetic, and you can see from here that this was the expected output, right? We sampled this. I took some data point to sample, right? And then we have this. So it generates sample code that you could make use of. So you have sample code in C#, you have sample code in Python and R. So we could actually take this and actually test in our Visual Studio Code or something. So we have this file here. So we can just paste this in. And then for the API key, it says we can use the primary or secondary key or the AML token for the endpoint. So using the primary key here, we can just copy, paste it in here, save and run this. and we should be expecting 0, 1, 1. So just the same way we expected, just the same way we expect we got when we did test. So copying the same values again, can make use of them here. Right, okay. Let me go back to copy it from this point. Okay, then we run. So we can see that we're getting 0, 1, and 1. So this is very simple, straightforward. And then this is just basically how you can deploy your models from your notebooks with Azure Machine Learning. So that will be it. Like I mentioned, we have some other resources that you could explore to get more insight into how this works, or how you could maybe even take it a bit further up into machine learning operations by using GitHub and GitHub Actions to automate all these workflows and all. So that's it. And then we know that after working with this, we need to delete all this, delete our computes, stop them, delete our endpoints and all that. So if you are experimenting as we're going on, or probably while you're following this later up, make sure that you delete all this so that you don't pile up costs and expenses of storage and compute on yourself. So if you need access to this particular slide, this is the link to get access to the slide. So just bit.ly deploy with Azure ML slide, and then you'll get access to it. Thank you for staying so far. And then thanks for all those that joined in this. We can have come to the end, and if you have any questions, you can just raise them up now before we end the meeting. Do we have any questions? Anyone with any questions or remarks or anything? So we can see the deployment logs here and all that. All right. Seems like we don't have any question. Can anyone just signify and like just say maybe you don't have any question or something? So you can see average requests per minute and all that. Yeah?
It's not a question, but can you go back to the link for the slide so I can take a screenshot?
Okay. Okay.
Thank you.
All right. I believe you must have gotten it by now. So thanks to everyone for joining in. Yeah.